All right, so today we're talking about tangent and cotangent. And I'm going to make this a fairly quick lesson. First of all, when we did the other ones, we had sine like this, and then we learned how to do secant, where wherever it touched zero, it made asymptotes, and then you go like this. That's not secant, it's cosecant. Sorry. Sine and cosecant kind of go together. Remember that one? Okay, so that was how do you do cosecant. Now we're doing a tangent. And for tangent, you have to start with a completely different mindset, because tangent is not its own function. Tangent is really made up of two different things. Tangent is sine over cosine. In fact, this is kind of a true statement. You don't even need tangent, because all tangent is sine and cosine put together. You just take the sine and you divide it by the cosine and you get tangent. Like if your tangent button broke tomorrow during the middle of the ACT test, all you'd have to do is take the sine of that angle and the cosine of that angle and divide them, and you would have the tangent. That's what it is. So let me prove that to you. Somebody that's got the calculator out, I know there's a few of you, would you grab, just if it's nearby and easy, would you grab it and tell me what sine of, I'm going to say 30 degrees, and cosine of 30 degrees are? Tell me what sine of 30 is. I know that one. 1/2, yeah, that's half, 0.5. How about cosine of 30? Somebody do cosine of 30 quick. Cosine of 30, point. Thank you, 866. Now would you take 0.5 and divide by 0.866? 0.5 divided by, got that one? 0.577. And now my point was that tangent is the same as doing this dividing thing. So why don't we just try tangent of 30, and I bet you it's going to come out to 0.577. It does. Verify. Okay. So what I just proved is that all you would really need is sine and cosine. You don't even need tangent, because tangent is just the dividing of this and this. Okay, and if you did tangent of 30 right off the bat, you jump to that. All right, so the point is tangent is based on sine and cosine. Why do we care? Because when we get to graphing tangent, we need to know when cosine is 0. Do you get that those are going to be the important points? Once cosine is 0, the whole thing is undefined. So that's where the asymptotes go this time. Last time it was wherever sine hits 0, we would make an asymptote. Now it's wherever cosine hits 0. So here's cosine. I'm just going to make it with a dotted line. There's cosine. And that spot and that spot are the key moments. That's where asymptotes happen. I'm going to use this kind and make the asymptotes there and there. And now to do tangents graph, oh wait, it's going to hit further if I go further. Okay, it's going to hit again a couple times. So I'll try it one more time. Adding a couple more of those pink lines up there and one there, and I'm missing one. You know, I missed. Sorry. I missed twice, actually. There we go. Okay, now, soon. All right. So now, I now need the actual graph. All I've got is like the boundaries. Where is tangent itself? It's like this. It's just a constantly rising graph. You know why I say that? Because it never falls. It just starts over again. It starts rising. It's sort of like a school year. School year ends, start another one over again. Okay? Just like this. Just like this. And now here's a common mistake though. People think that it takes 2 of these to make a full period. It doesn't. You know how on the other kind you'd have these loops that were like one up loop and one down loop, and that would complete one full period, one up and one down made a full period? This only takes 1 of these cycles to make a full period. So like one set, like I'll do another one over the top of red here, like that is a complete set, a complete period of tangent. So it's not 2 pi anymore. Its period is how long it takes to get from here to here, and this is a half a pi from here to here, and this is another half a pi from here to here, so the total would be pi. The period on this puppy is pi now, not 2 pi. That's for the wave ones. The wave ones take 2 pi to finish. These complete a full cycle in pi. All right? Now, if you think you understood that, would you please, on your own with a blank piece of paper, start with a blank one or go to the next page or whatever. Because the reason is I'm about to ask you to do the same thing you just did 2 seconds ago. Sketch me tangent, except do it faster this time. Remember, it's based on tangent, sine over cosine, so it's wherever cosine is 0 that makes your little line. Once you got your little asymptote lines in there, super easy. So tangent, sine over cosine, wherever cosine is 0 is here's my cosine dot. And wherever it hits, I'm going to make asymptotes. Asymptote here, here, here. That's good enough. That's going to make 2 periods. When I make 3 asymptotes, I can make 2 periods of it. Quick sketch. Raise your hand if you were doing it right. Okay, good. That's tangent. That's the graph of tangent. So what if they ask you to change it to like y equals 2 tangent? All I got to do is take this 2 and make this number that used to be 1, like normal's 1 and negative 1, and you change those to 2's. You don't have to change the graph. Same deal as before. And let's say I throw in like a 6 right there. Then here's something that's a little trickier. The period used to be 2 pi over b, but you got to get that out of your head because the period isn't 2 pi anymore. The tangent period is pi. So you're going to have to remember to take pi over b. And b in this case, since I threw a 6 in here, is pi over 6. So how do I do that now? Well, go back to the original numbers. I'm going to just wipe this out and say, you know the original 4 numbers? They're always the same. No matter if sine, cosine, tangent, all the sister functions to them. You always start with 2 pi at the 4th mark. Always. The way we're teaching you this, you can always just go like this. If you have those numbers memorized, you're golden. Like half the test on graphing is about the x-axis. Those numbers right there. And then you have to change them. So like, we just did that one with tangent. So we had tangent of 6x. We have to change these numbers. And the normal period of tangent, it normally gets over with in a period of pi. So the period is pi normally. We divide it by b, divide by 6. So now pi has to become what? Pi over 6. And if I change pi to pi over 6, what did I do to it? I multiplied it by 1/6. I have to do that to everything. 6 makes pi over 12. Multiply it by 6. It's going to make 3 pi over 12, which gets reduced, by the way, to 4. And then this last one times by 1/6. 2 times 1/6 would be 2/6, which would be 1/3 pi or pi over 3. There's my new numbers. I'm telling you, the biggest part, hardest part of the test is that part I just showed you right there, renumbering the x-axis. And you got to remember that it's not 2 pi for tangent, it's pi over b. Yes, sir. If the only thing you didn't do is reduce 3/12 or 3 pi over 12, I probably wouldn't have marked it wrong. But I'm not telling you that you can do that. I'm telling you that in a really complex problem, I might overlook one little thing like that. Now, if you just generally didn't reduce anywhere, try to remember to reduce. Okay, so again, tangent, generally you've got, here's a really quick graph of it. Dotted line, there's tangent. Could have just told you that. Okay, but the problem is that it's more complicated than that because of the numbering. But that's generally what tangent looks like. And now cotangent. I've got a nice slide for tangent and cotangent. They're based on, like the cosine and sine, just like you're based on your mom and dad. And I did make this out just because I thought it was kind of cool. I looked up the formula. There is a mathematical formula that's like 98% accurate. If you take your parents' heights and your grandparents' heights, and you divide by 6, which just means average them. If you average your parents' and your grandparents' heights, and then you multiply by 1.08, if you're a guy, you're going to be slightly higher than the average. See, this is an 8% increase above the average. That's what you're doing there. that'll be within 2 inches of the exact height that you will be. Okay, now of course there are always situations that are weird. You know, somebody's got a growth on their pituitary gland or something, and they grow to be like 6'9" and shouldn't normally be, but this is normal. That's the vast majority of you would fall into that range. Average your grandparents. If you're a guy, multiply by 8% bigger. If you're a girl, go by 8% smaller, because again, you're averaging in guys, not just girls. Right? So you average your moms and your dads, grandmas, grandpas. If you're a girl, you shrink it by 8%, and then again, it's only off. If you add 2.5 to 4.5 to that number, you'll only be off by within an inch or two of your exact height. So anyway, those of you that are really curious, how tall will I end up being? Find out how tall Grandma and Grandpa are on both sides, or were. If you had like one really short person, you know, like I did, my dad's mom was super short. She's like 5'0". That means I'm probably, you know, I was probably doomed by that to not be able to be very tall, just because the average, you throw that one person in the average and it brings it down. Anyway. Okay, anyway, when you are a full-size adult, yes. And yes, this can be affected, like if you don't get good nutrition. I know you've probably heard mom and dad telling you to eat well. It is actually true. They have countries where people are like 2 or 3 inches shorter than they should be based on not having enough nutrition. And one of the interesting trends is, for instance, in China, they have people that are getting significantly taller than they were years ago because they're getting good nutrition that they didn't used to get. And as they're getting better nutrition, they're growing taller. So, anyway, let's move on. And I want to make sure I maybe this is you add this number, but obviously adding 3.5 to 5.5 is a range of 2 inches. That's why you could be off by an inch or two, but this gets you at least pretty close to the right height. All right. Anyway, and then I had some stuff. It's interesting. Napoleon with the hat, still quite a bit shorter. He's probably the tallest leader we've had around in a long time. And look at those European dudes. Anyway, moving on. I think we're going to jump right to the cotangent one, because I already showed you tangent. Here's cotangent. Remember, that's a flip, so it's not sine over cosine, it's cosine over sine. And that means when we graph this puppy, we have to, I'm not going to ignore this 2 for just a minute. I'm going to say cotangent is, let's see, I'm trying to make sure I get it right now. Sine over cosine is the normal one, so it's cosine over sine. So I got to look for wherever sine is 0. So I graph sine quick. There's sine. Maybe I'll just continue it out. Okay. And wherever sine is 0, that's where the asymptotes are. Asymptote, asymptote, asymptote. And it's this, once you got the asymptotes, it's not the same swoosh. If this was a tangent graph, the swoosh would be looking like this. Got about 3 minutes before lunch. That would be the tangent graph. So it's not that way. It's, hold on a second. I'm having alignment issues, sorry. Okay, I'm just going to try again. Tangent was different. Cotangent, they don't swoosh up like this. See if I can do it now. There we go. They go down like this for cotangent. So once you got the asymptote lines, it's really, really easy to just finish the graphs. And there we go. Now, did I do 1 period of it? No. I did 3 periods of it. Every swoosh is a full period. And how big are the periods again? They're not 2 pi? They're pi. All right, so final thing that you have to know how to do. Let's say that we had a cotangent one, and we're going to put a 3 there. Well, now, to start with, you just make a normal cotangent one. And cotangent depends on wherever cosine over sine, wherever sine is 0. So where is sine 0? I'm going to make a quick thing like that to remind me. Okay, so that's where the asymptotes go. Now, cotangent goes like this. There, it's that quick to make cotangent. But I have this 3 to deal with now. Well, normal numbering would go like this. Pi over 2, pi, 3 pi over 2, and 2 pi. Would you agree with the normal numbering? Now I just have to change it from normal to something else. Normally the period is pi, remember we're cotangent here, pi over b. B is 3. So pi needs to change into pi over 3. So you go down here, you cross off pi, and you say now you're going to be pi over 3. And then you ask yourself, what did I do to it? I multiplied it by 1/3. 1/3 times this, pi over 6. 1/3 times this, pi over 2. And 1/3 times this, 2/3 pi. 2/3 pi. Cross it out. There we go. Okay, lunchtime. Okay, we're back from lunch, and we're just going to do one more. This time, I want to do cotangent, and I want to stretch it. So to start with, would you please just put up one of these, make the 4 marks, and number them. That's how you should start every single graphing problem on the test, is to make the 4 marks and number them. Even people from foreign countries who are devaluing their currency need to do this right. Did you hear about that? Just did a big devaluation, and they did it right before the weekend. Ticked off a lot of people. All of a sudden, prices went crazy when you devalue. So people were running into stores and buying things up real quick while they could still get them at the old prices. Anyways, it's a news story as of today. So. Mm-hmm. Mm-hmm. Yeah, that's a major difference. Just for perspective, what that means is like prices have, quadrupled over the last 3 years there. So like if you wish to go in and get a hamburger for, like $1, now it'd be $3 for the same exact hamburger. Or mm-hmm. Mm-hmm. Gotcha. So if you're going to start, you're going to start with what? Sine or cosine? If we're doing cotangent, cotangent is, I would always write this out if I were you, not sine over cosine, it's the other way around. Cosine over sine. And so I really need to know where sine touches. Here's the numbering we were talking about. And if I were to graph sine, it basically goes something like that. And now sine touches 0. That's going to mean it's 0 on the bottom. That's going to mean it's going to not work. So therefore I need asymptotes there, and there, and there. And cotangent is not going up all the time. It's going down all the time. That'll help you remember which way to draw this thing if it's going down all the time. And there we go. I got 2 periods of cotangent. But I wanted to do cotangent except stretched. So I'm going to now just do one little difference. Notice, it doesn't even matter that I stretched it until right now. So if I put a 4 right here, now I'm just going to go back and renumber stuff. Okay, so I've done it perfectly. I just need to renumber these numbers right here. Because now I'm going to say the period, which was normally pi, has changed to pi over 4. Pi over b. Right, so pi over 4 is what pi is. Now I cross off pi, change it to pi over 4, and let's see if you can get the rest of the numbering right. So what am I timesing everything by? 4th. Yep. And that's going to make this pi over 8. Times by a 4th. 3 pi over 8. And the last one is times it by a 4th into 2 pi over 4, which would reduce to pi over 2. There's my new numbers. That was the hardest part. Okay, that's all I got for you for today. Especially because we have a singing telegram coming in.